All right, we are back with number 8. Here we go. So we want to divide this by x squared plus 1. Okay, so I got x squared. What the heck? Oh boy. Let's try that again. Pen. Here we go. X squared plus 1. I'm going to need some placeholders here, so I have 3x to the 5th plus 0x to the 4th plus 2x cubed plus 0x squared minus 3x plus 1. Okay. So, here we go. What do I need to multiply to x squared to get 3x to the 5th? Remember, you can do this little trick where I divide my first terms. Okay, divide these terms out. Alright, well, I need a 3. And I have 2 and 5, so 5 minus 2 gives me the third power. So that's what I'm going to write up here. Remember, I multiplied this term here, 3x to the third, times each term. So times x squared, which will give me 3x to the 5th, and times 1, which would give me 3x cubed. Sorry. When I do this, alright, when I'm doing this long division, okay, I need to change my signs so that I can cancel some things out. So this was positive 3x to the 5th, now it's negative. Positive 3x cubed, now it's negative. Okay, these cancel out. I have 2x cubed minus 3x cubed to get negative 1x cubed. Again, what do? Okay, I'm going to divide negative 1x cubed over x squared and get negative 1x. Well, that's what goes up here. Negative 1x or negative x, same thing. Multiply it to negative x squared to get negative 1x cubed. Well, I got to bring down plus 0, 0, there it is, 0x squared minus 3x. I'll leave the 1 there for now. Okay? So I multiply the negative 1x to the first term and multiply the negative 1x to my second term to get negative 1x. Now remember, when I add, I need to flip my sign, so this becomes positive and this becomes positive as well. These cancel out. There's nothing here with the x squared, so I just kind of ignore it. Okay? And then I have negative 3x and 1x to get negative 2x. The plus 1 is still here. It just comes down. Okay? So my answer, 3x to the third. How do I know that I'm done? Sorry, forgot to say this. How do I know that I'm done? I stop because the power here, okay, the degree, the power of my x is 1. Here I have a squared. If I cannot multiply anything to x squared to get x. Okay, so we stop there. When the degrees are less, you stop. Remember, our remainder becomes a fraction where it's my divisor, what I'm dividing by, in the denominator, and my remainder on top. So that would be final answer. Right there. Right there. Here we go. Number 9. All right. So, possible zeros. All right. Well, here's the deal. I'm going to write, remember, this is my P term. This is my Q term. Luckily for us, our Q is 1. So I'm just going, really, I just do P over Q. But if Q is 1, then it doesn't really matter. So I have plus or minus 1. Plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 9, plus or minus 10, plus or minus 20, and plus or minus 40, all over plus or minus 1. So my possible zeros are the numerator. Plus or minus 1, 2, 4, 5, 9, 10, 20, 40. Boom. Okay. Next thing I need to do, find all zeros of my function. Well, I don't have the TI Inspire. I don't have a graphing calculator to show you. Let's see if I can pull something up to figure out which one is a zero. I'm going to pause this for a second. Alright, so I chose to use Desmos to graph this so you can see it. If you look here, you could also look in your graphing calculator and look at the table. If you look here, I can see that, okay, -4, 0 is a point, and 2, 0 is also a point. So I could use either one of those two, alright, to plug in. I'm going to start with -4. Do synthetic division with -4. Okay, now, I recognize that there are only two spots in which my graph crosses the x-axis. However, just because there are only two spots that I can see, does that mean there aren't any imaginary roots? Alright, so make sure you complete this process no matter what. Okay. Find all zeros. Well, my leading coefficient is 1, 2. I don't have any placeholders here, so I just go straight across the top. And that is a lot. That's so nice. How nice is that? That's pretty neat. How neat is that? That's neat. Okay, so now when we use synthetic division, first number gets dropped down. Multiply what's here by what's in the box. 1 times -4 is -4. -4 plus 2, -2. -2 times -4 is 8. 8 plus -3 is +5. 5 times -4, -20. -20 plus 10, -10. -10 times -4, 40. To get a 0 here, which is good for us, right? Which told us that -4 is in fact a 0. Okay, so now, since my degree of my polynomial was 4, I started with x to the 4th. Okay, that means the degree of my next polynomial is going to be 1 less. So I'll have x cubed, or 1x cubed, minus 2x squared plus 5x minus 10. 4 terms and it's a cubic. I'm going to 2 by 2 group, set this equal to 0, alright, and solve. Take out an x squared. X minus 2. Oh, something in my eye. Of course. 5x and -10. Take out a 5. Take out a +5. And I'll have x minus 2 equals 0. Wow, x minus 2's match. X minus 2 and x squared plus 5 equals 0. Alright, I set this equal to 0, so x equals 2. I'm going to set this equal to 0 here. X squared plus 5 equals 0. Subtract the 5, x squared equals -5. Square root both sides. X equals plus or minus square root of -5. I need to take the I out. I radical 5. So it says find all zeros of the function. Well, all my zeros are listed here. 2, 0. I root 5, comma 0. negative I root 5 comma 0. But I should have 4, right? Because it's a 4th degree polynomial. Well, don't forget negative 4. Again, you don't necessarily have to have 4. You could have some double roots. But in this case, we do have 4. I just said that just to make a point, to not forget why this looks like a smiley face, but it's really a 0, okay? All right, don't forget this 0 right here. Okay, to write these as linear factors. 2, 0. Well, I know what this is. X equals 2, so x minus 2 is the factor. I'm just going to lose my mind. I mean, I have to stop. I lost my cool a little bit there, but x minus 2, all right, I know that negative 4 was a 0 as well, so x plus 4 is the factor. Okay, I had positive I root 5 and negative I root 5, which means I'll have x minus I root 5 and x plus I root 5 as my other linear factor. So this is a completely factored form. Yes. Oh my gosh. Okay, number 10. Here we go. I have 4 terms here. All right, 4 terms tells me I want a 2 by 2 group. Okay, I take out an x squared here to get 2x plus 5. Take out a negative 2, or excuse me, negative 4 here to get 2x plus 5 less or equal to 0. X is a 4, remember. Squared minus 4. And 2x plus 5 less than or equal to 0. X equals negative 5 over 2. And this is going to be plus or minus 2. So my pairs here, I got negative 5 over 2. I'm going to space these out just because I don't want to write them right next to each other. I know. 2. Okay. The checking portion. All right. So if I want to check for my solutions, check which intervals work. I want to check our first interval here. So I'm going to plug in a number less than negative 2.5. So x equals negative 10. If I plug it in here, okay, this is going to be, remember, this is x plus 2, x minus 2 times 2x plus 5. X plus 2, x minus 2. All right, so if I plug in negative 10, I'll have a negative, and a negative number, which will result in a negative number, which is less than or equal to 0. So this interval works. If I plug in a number between negative 2.5 and negative 2, I'm going to do negative 2.4. I'll get a negative times a negative times a positive, which is a positive number, which is greater than 0, so this interval is out. A number between negative 2 and 2, I'm going to plug in 0. If I plug in 0, I get a positive, negative, positive, which gives me a negative number, which is less than or equal to 0. Oh my God, I can't lose my mind. I'm going to lose it. So this interval checks out. That's a check mark. This thing does not. Lastly, I'm going to plug in x equals 10, a number greater than 2. All right. If I plug in 10, I get 3 positive numbers, which gives me a positive number. So that is out. Okay. So the only 2 intervals that work are here. So negative infinity to negative 5 over 2. Because this says less than or equal to, I close these dots and I include it in the bracket. So I write a bracket here. All right. Union negative 2 to 2. Both brackets. All right.